So far what we've been doing is talking about factoring. Now the reason why we want to factor is because we want to be able to solve quadratic equations. So far we've just been looking at factoring expressions, and especially quadratic expressions, but we want to look at how can we actually solve, how can we actually find out what x actually equals or y actually equals in our equation. And so what we want to do is we want to look at the steps for solving quadratic equations using factoring. Okay, so let's look at the solving quadratic equations using factoring. So when we do this, step one is to write the equation in the form of ax squared plus bx plus c equals 0. The most important thing here is that we make sure that we have solved it to where it is equal to 0. We have everything on one side of the equal sign and 0 on the other side. Then the second step is we want to factor the quadratic expression completely. And it's very important that we factor it completely because otherwise it's not going to let us solve or anything. And then the third step is we are going to apply the zero product rule. What that means is we're going to set each factor equal to 0 and solve the resulting equations. So what the zero product rule means is if I have two things multiplied together and their product equals 0, one or the other one must equal 0. For example, if I have 3 times x equal to 0, that's 3 times x, and so my x I know has to be 0 because in multiplication, in order to get 0, one of my items has to be 0. So that would mean that x is actually 0. Same thing happens if I have x plus 2 times an x minus 3 equals 0. What this tells me is that either this factor or this factor must be 0. Doesn't matter which one, but one or the other of these factors must equal 0. So what we have to do is where we solve the zero product rule, we're going to set each factor equal to 0, and we're going to solve the resulting equations. And when we do so, we're going to get two numbers that will make this equation true. So whenever I do that, I subtract 2 from both sides, because remember, if I'm adding 2, the opposite of adding 2 is subtracting 2. That way these two, a positive 2 and a negative 2, cancel each other out. And I get x is equal to a negative 2. Come to the other equation, x plus 3, or I'm sorry, x minus 3. So the opposite of subtraction is addition. And what happens is, whenever I move it across the equal sign, that's when I want to change the sign because I want to cancel these out. And that gives me x is equal to 3. Both of these, if I plug each one of them in individually to this equation, will make this equation true. Because look, if I say that negative 2 plus 2 times negative 2 minus 3, does that equal 0? Well, negative 2 plus 2, that's equal to 0. And a negative 2 minus 3, that's a negative 6. Well, 0 times a negative 6, that's 0. So yes, this one works. Same thing applies for the x equal to 3. If I say 3 plus 2 and 3 minus 3, does that equal to 0? Well, 3 plus 2, that's 5. And 3 minus 3, that's 0. 5 times 0 is 0. So yes, that one also works. So notice there are two correct answers here. And I will get into showing you some of the ways you can tell how many possible answers there will be. So let's look at some examples on where we need to factor and solve things of that nature. So if they're already factored for us, such as x plus 8 times a 4x plus 1 equals 0, first question is the equation set equal to 0? Yes, it is. So if that's the case and it's already factored for us, I'm going to set each factor. So I'm going to set this factor, x plus 8, equal to 0. And I'm going to set this factor, 4x plus 1, also equal to 0. And I'm going to solve these two equations separately. So x plus 8, opposite of adding 8, is subtracting 8. So I'm going to subtract 8 from both sides. And I get x is equal to a negative 8. Over here, 4x plus 1 equal to 0. I'm literally undoing my order of operations, so I want to undo the addition subtraction first. So the opposite of adding 1 is subtracting 1 from both sides. That way, these two numbers will cancel out, leaving me with a 4x equals to a negative 1. Well, I still don't have x equals. I have 4x equals, but I need to get x by itself. So I look and say, okay, how are these two attached to each other, 4 and x? That's an understood multiplication there. So what's the opposite of multiplication? Division. So I'm going to divide both sides by the number that is attached to the x, or to my variable. And I want to divide it by the same sign also. So if this is positive, I want to divide by a positive. If it's negative, I want to divide by negative. That way, 4 divided by 4 is 1, or leaves me with just an x. And then negative 1 divided by 4 leaves me with a negative 1/4. And again, I can plug both of these answers in, same way I did just a moment ago, to check to make sure that I solved it correctly. So my answers would be x equal negative 8 and a negative 1/4 for this particular problem. Let's look at one that is not already factored for us. So let's look at if we have 2x squared minus 9x equal to 5. Okay, Remember our steps for solving quadratic equations. The very first step is to make sure that it equals 0. Well, does it equal 0 right now? No, right now it equals 5. So what I've got to do is I've got to move this 5 to the other side of the equal sign. In order to move it to the other side of the equal sign, I have to change its sign so that these will cancel out. And I get 2x squared minus 9x minus 5 equals 0. And I combine like terms if I can, but notice I've got an x squared, an x, and then a number without an x. So I don't have any like terms to combine. Now that I have this equal to 0, what I'm going to do is I'm going to factor this 2x squared minus 9x minus 5. And remember that when we're factoring this part right here, I need to find out what my a is, my b is, and what my c is. So my a is 2, my b is a negative 9, and my c is a negative 5. And it's a negative 5 because I had to move it across the equal sign. Then I'm going to say what multiplies a times c, so that's a 2 times a negative 5, which is a negative 10. So what multiplies to give me a negative 10 and adds to give me my b, which is a negative 9. So I want to multiply to give me a negative 10 and add to give me a negative 9. Well, a positive 1 and a negative 10 will multiply to give me a negative 10, and they will also add to give me a negative 9. So these are my magic numbers that I will use. And as I've said before, if I have one positive and one negative magic number, I tend to put the negative magic number first when I separate out my b. So I'm going to do negative 10, keep my variable x, plus 1, keep my variable x. And then I'm going to bring down the x squared minus 5 equal to 0. Now I'm going to factor this by grouping. So I'm going to group these two terms together, and I'm going to look and say, okay, what number will go into 2 and to negative 10, which is a 2. Oh, I need to leave me a little bit more room because I also have an x that will go into both of those. So I take out a 2x, which leaves me with an x, and if I divide 10 by 2, that leaves me with a 5, and my x is gone. Then I look at these two. Remember, I always take this sign, and then I look and say, okay, what's common? Well, nothing is really common, so I'm going to take a 1. Remember, you have to take something, so if you can't take anything else, always take a 1, which is going to leave me with an x minus 5, still equal to 0. I still have not finished because I do not have a parentheses times a parentheses yet. Are my parentheses the same? X minus 5, x minus 5. So yes, x minus 5, and then I'm going to put my leftovers, 2x plus 1, in the other set of parentheses. And I still have it equal to 0. Notice I still have this equals all the way down. Now I have one thing times another thing equals 0. Once you have it to that point, this is where we can apply the 0 product rule. And we can set each one, x minus 5 equal to 0, and 2x plus 1 equal to 0. And I'm going to solve these. So I'm going to add 5 to both sides, And the reason why I'm adding is because that's the opposite of subtracting. So these two will cancel out. That leaves me with x is equal to a positive 5. Now on this other one, I need to undo my addition subtraction first. So I'm going to subtract 1, and that leaves me with 2x is equal to a negative 1. I still do not have x by itself. This is 2 times x. Opposite of multiplication is division, and I divide again by the number that is attached to the x, so that these two will cancel each other out, leaving me with x is equal to a negative 1/2. Now remember that I started out with the equation 2x squared minus 9x equal to 5. So what I want to do is I want to put each of these x's in here to see, do those match up to equal 5. So I'm going to have 2 times 5 squared minus 9 times 5. Let me change that to black there. And does that equal 5? So let's see here. I've got to do my exponents first. So 5 squared gives me 25. And that's times 2 minus 9 times 5 is equal to 5. 2 times 25 is 50. 9 times 5 is 45. And then 50 minus 45 is 5. So x equal 5 does work. I'm going to do the same thing with the negative 1/2. It's going to be a little bit more difficult because it's a fraction, and I know how most people don't like fractions. So I've got 2x squared minus 9x equal to 5. So that's 2 times a negative 1/2 squared minus 9 times a negative 1/2. And what we're trying to do is see if that equals 5. So a negative 1/2 squared is like saying negative times negative gives me a positive. 1 times 1 is 1. 2 times 2 is 4. So that gives me a positive 1/4. Minus 9 times a negative 1/2. And we're trying to see if that equals 5. Multiplying fractions, I'm going to put my whole numbers over 1, and I'm going to multiply straight across. So 2 times 1 gives me 2, and 1 times 4 gives me 4. Negative times negative is going to give me a positive. 9 times 1 is 9. 1 times 2 is 2. And we're still trying to see if that equals 5. To add fractions, they must be the same. But notice right here, 2 divided by 4, I can simplify that into 1/2 plus 9/2. So 1/2 plus 9/2 actually gives me 10/2. And 10 divided by 2, or 10/2, is the same thing as 5. So both of these check out. X is equal to 5, and x is equal to a negative 1/2. So you can see that whenever we have to factor it, the very first thing we have to do is make sure we set it equal to 0. Let's look at another example, because sometimes it may be that we can factor out a common factor first, or maybe we can simplify first, anything like that. Okay, so if we have 4x squared plus 24x equal to 0. Well, I don't have 3 terms, but this is already set equal to 0. So what I'm going to do is I'm going to try to see if I have a greatest common factor. And I do. My greatest common factor is a 4x. So if I simplify a 4x out, or factor out a 4x, that's going to leave me with an x plus 6 equal to 0. What happens in this case is I have this item times this other factor. So it's like I have this one factor times this other factor. And so I'm going to set these two factors equal to 0. 4x equals 0, and x plus 6 equal to 0. And I will solve from there. So in this case, I have no addition or subtraction to undo. So I'm going to first look and say, okay, this is 4 times x. Opposite of multiplication is division. So I'll divide both sides by 4. And I'll get x is equal to 0, because 0 divided by anything is 0. On this other equation, x plus 6 equal to 0, I undo the addition subtraction, so the opposite of it, adding 6, is to subtract 6. And I get x is equal to a negative 6. And when I check this, plug in a 0 for both my x's or a negative 6 for both my x's, I find that both of them work and check out. Notice that most of these so far have had 2 answers, and that is because we've been dealing with quadratics with an exponent of 2. If I have something that has an exponent of a 3, such as x to the third plus 36x is equal to 12x squared. First thing I want to do, I'm trying to solve this, so the very first thing I want to do is set this equal to 0. And so I'm going to subtract 12x squared. When I do so, I want to make sure that I put it in the correct order. So I've got a 3 as my exponent here. I want the 2 exponent in the middle. So whenever I rewrite this, I get x to the third minus 12x squared plus 36x equals 0. Remember, I always want to write my highest degree to my lowest degree terms. And then I'm going to say, okay, can I factor anything out? What is my greatest common factor? Well, my greatest common factor is going to be an x. So I'm going to factor out an x. That's going to leave me with x squared minus 12x plus 36 equal to 0. At this point is whenever I can factor this x squared minus 12x plus 36. So I want to find what multiplies to give me a positive 36, but adds to give me a negative 12. And I could go through the list, and it's best if you do, but I already know that it's going to be negative 6 times a negative 6 is going to add up to a negative 12. And so I get negative 6x and a negative 6x. I'm going to keep my x on the outside. and I have to be a little bit careful whenever I start factoring. I look here and I say, okay, I can factor out an x, which leaves me with x minus 6. I look here, I have to take the subtraction sign, and I can factor out a 6. And remember, since it's taking a subtraction sign, it's going to change this sign, so it's going to be x minus 6 equals 0. My parentheses are the same, and so I'm going to end up with x times x minus 6 times an x minus 6 equal to 0. I get the first x minus 6 from my parentheses. My second x minus 6 comes from this x and this negative 6 here. When I go to solve these now using the zero product rule, I'm going to set each of my factors, this factor, and this factor equal to 0. Notice how many factors I have. I have 1, 2, 3. If we go back to our very original equation, what was my largest exponent? It was also 3. Whatever your largest exponent is here, that's how many factors you should have in order to solve these quadratic and higher order polynomials. So I'm going to set x equal to 0, x minus 6 equal to 0, and x minus 6 equal to 0. Well, x equal to 0, that's just 0. On both of these are going to be the same because if you notice, x minus 6 and x minus 6. So I will add 6 to both sides and get x is equal to 6. Do the exact same thing to this one. So really, these two are the exact same. So whenever I have my answer, it is x equals 0 and x equals 6. If you write down the 6 twice, that's fine, because you know from up here you should have 3 answers. They may just duplicate each other is the only thing. Okay, so look at that largest exponent and see what it is, and that should tell you how many answers you should have down here. Again, it could duplicate like it did here, or they could all be completely different. So what I want you to do is I want you to work on solving quadratic equations or those that can be factored down into quadratic equations, and let me know if you have any questions.